Alright, good morning everybody. Today I wanted to talk to you about my Airwolf a little bit. Since I got this printer, I've done a few reviews, everything. To date, this is probably still one of my favorite printers, and it is the Airwolf HD2x printer. I said from the beginning this is a workhorse, and it is. I still have the original extruders installed, and the gears still are great on them. They're nylon gears. The only problem, as I said in the previous video, is if you do a whole lot of printing on this printer, the design for these gears, this arm that goes on that extruder, it does wear down. And when it wears down, and where it wears at is right there between them springs, you can see that little spot. I'll get a screwdriver or something and point at it for you. Right there. Sorry about the focus, but it wears right there on that spot. And when that wears, it starts skipping. Now, this is printed 100% infill. I can tell you it is heavy. They are to either print this and make a metal insert for this right here, or just have this one part machined from aluminum or something. I do know, hey, if it added $5 to the cost, because if you do it in bulk, it can't be that much. But they won't give you the STL for it. You have to order it. If it goes bad and you're out of warranty, you have to pay for it. So if you're in warranty, they give it to you for free. I mean, paying for it, what is it, $6, $9, somewhere in that area, I think. It's not much. But, if you don't keep an extra on hand and this wears out, then you're stuck not printing till you get one. Mine was in warranty when they shipped me this one. And all I did, because I never really used the second extruder that much, I just changed all my prints to print off of that extruder instead of that one while I was waiting for this to come in. So I never really did nothing with it, because when 3DP ran their sale last year, I bought their dual extruder. This is a gear drive system, and then I of course made this myself, and I did upload the STLs for this to Thingiverse. But if you keep an extra arm around, these extruders are great. I'd never ever had a problem with them, but until this wore. So, and once it starts wearing, you start getting things like it doesn't feed, then it'll jam because it just sits in there. You get a few odd and end errors. At first looks like it's a hot end problem, but it's really this. So anyway, you can do something like these, or put bulldogs on there. Now if you do that, you have to adjust your firmware, because the steps are different on the geared ones than they are on those. But hey, it's whatever you want to do. It's still a workhorse machine. This is the second version of this head. They replaced this under warranty. My original one was the first version. The second version has two fans. As you can see, there's one on the back, which that's what was with the first one. Or no, that wasn't. This fan on the back wasn't on the first one. It was only this fan, which blowed down through here, and it was supposed to cool this if you needed to, but it's supposed to cool down here for PLA. They added the second fan. That this fan is set by firmware to come on when your hot end reaches 100C, and it blows across these fins just like a 3D or a E3D fan does. But it doesn't come on to 100C, which, hey, I guess that's neat. But they replaced this under warranty, because I was still in warranty when this came out, so they sent it to me for free. I thought that was pretty cool of them. Now, because I did print a lot with the other one, and all you gotta do to take this off, you pull this back and it'll pop out of them bearings, and then I can pull it this way and it comes out of that bearing. Okay, let's turn this over. It is a little bit of a mess. I haven't cleaned it. Alright, so even on my other one, and if you notice, you see that? There's a reason those wires look like that, because that is not Airwolf's. Airwolf uses a heat resistor, and whoops, the On theirs, a lead comes out of both sides and goes up. On my other one, because I printed so much, within 6 months the heat resistor died. This one died on me yesterday. So all I did was take an extra heat cartridge I had. Now here's the kick: when you do this, it'll quit heating. Hey, it's the heat resistor, or whatever you want to call it. I cut the leads. First you got to take this apart. To take this apart, all you do, you take the 2 screws out of the top, pull this off the top. Now if your filament's in there when it goes out, you have to pull this back. You have to take the pin out to hose the arm up so it's free if you're using these, or however you got to do it to free your filament. Pull these back so you got about 1.5 inches, 2 inches of filament sticking up. Cut it off. You don't want to cut the filament off flush, because once you get done, you need to heat this up and pull that filament out to feed the new end. If not, you're trying to push it through with the other filament, it can cause problems. So 2 screws, pull this back, cut the filament off with about 1.5 inches sticking up. Okay, now once you do that, your next thing is going to be to take and loosen these 4 screws up in the bottom, thinking that's what's holding the head on. It's not. Okay, and that screw is an adjustment for the tilt. When it's on there, that screw adjusts it this way. So all you do once you take those 2 screws out, you carefully, you see that lip right there? You carefully pull this up so it comes back and over, and this whole top comes off. Once it does, you'll see the wires. All you got to do is cut the two leads to the heat resistor, and then you got to get that heat resistor out. And all I did was take a pair of needle nose, grab the lead right there at the heat resistor on both sides, and just twisted it till it come off almost flush. Then I took, and you can use a punch or whatever you want, I used a 4mm Allen wrench. I put it on top of the heat resistor, held this in my hand. You don't want to lay this on your printer and beat on it, you know. Held this in my hand and just started tapping on the top of this. You can see where I tapped it right there. I actually tapped it with an Allen wrench a couple of times, and then I just used my scraper, which is right there. I used to handle it. I hit it about 4 or 5 times. The heat resistor come out the other side, and it was out. I took one of my heat cartridges, I shoved it in there, and the first thing you're going to notice is, hey, this ain't going to stay. It's real sloppy, because it is. So you got 2 options there. You can drill this out and tap it and put a grub screw in, which is a great idea. Unfortunately, I had something I wanted to print last night. I didn't have time to drill it. I didn't have the tap to tap it. So what I did was I took some copper wire, and I'm not sure, this is 16 gauge copper braid. It's braided, but it's 16 gauge total. I separated the things. I took 6 pieces of that wire, about 1.5 inches, 2 inches long, and I stuck them through the hole, and then I put the heat cartridge in, and it was just for shims basically. And then I had to take a pair of pliers and actually, you know, grab the heat cartridge from it, put the pliers on this side, grab it from this side, and squeeze it into place. And it is not moving. It's not going nowhere. It's in there. It's shimmed out. It's working. The grub screw would be a better choice. The next time I replace it, I will put the grub screw in. Once you do that, you make the 2 wiring connections, and you're done. You now have a heat cartridge instead of a heat resistor. First thing you're going to notice with this upgrade is this thing heats up a lot quicker, gets to your temperature, and it holds it a little bit better, you know, because the heat resistor takes a little more time. So but when the thermistor says it's getting cold and it kicks on, it takes a couple of minutes to catch up. The heat resistor does a better job of it. I did this to the other one, ran it for 6 months. I never had a problem. As a matter of fact, it was funny. I got in these new plates that I just did a review on, and by the way, it works great. This is a Gecko Tech plate. I have flex plates. I have the Rhino plates, or the Zebra plates, or the Print and Z plates. I have Build Tack. This outperforms all of them. I love the Build Tack. Now Build Tack also now makes a plate, but their plate is a metal plate like this with their Build Tack layer on it. This is just a plate, but it does have some kind of film on it. Works great. You know, you got to, and you can see the little imprint there. That's just residue it leaves. You take alcohol, you wipe that off. You got to be real careful never to get this hot end touching this, because it ruins that surface, and then it's junked at that point in that spot. So always go a little higher. Watch my review on it. We'll get back to the hot end. But that is a great upgrade. But once I got this upgrade, as I was trying to tell you, I put this in yesterday, did the review, went to make another print, and my hot end wouldn't warm up. I looked at it and thought, well, I didn't pre-warm it, so maybe it's taking a little while. I came back, it still wasn't hot. I said, man, and I just thought to myself, that heat resistor's lasted longer than the other one did, and literally within 24 hours of saying it, it went out. So for anybody that's got an Airwolf, you can replace that with a heat cartridge. You can either shim it out like I did, or you can just tap that and put a grub screw in. Either way works great. This definitely makes the heat up times a lot better, and you're not trying to get parts from Airwolf and wait on them. Don't get me wrong, like I said, I still really love this printer, and actually if they would make the Axiom probably a little more cost competitive, I would probably buy one. So, but you know, $5,000 to $6,000. I mean, I paid almost $4,000 for this thing, and you know, you can get these on eBay now anywhere from $800-900 to about $1,200 with the dual extruder setup on them, and I think it's totally worth it. I mean, if you're getting into 3D printing, that would be the way to go, because even if a part goes bad, this is actually set up on a rip-wrap design. I mean, you know, other than having to deal with a few of their firmware tweaks, I mean, the parts and stuff, you can make it all work with standard parts. It just takes a little bit of work. There is even a thing on Thingiverse. Somebody's made a new block that mounts on here, and you can use 2 E3D hot ends. And I have seriously considered going that route, because on the Axiom, these 2 hot ends are separate, and they have separate heat. On this one, it's one heater, and they have the same heat for both of them. That gets you into some trouble with some filaments if you have 2 totally different filaments on there. So, just a little food for thought. But if you have one of these, and just because your heater cartridge dies or something, you're not SOL, you're not waiting on Airwolf, you can get a heater cartridge, put it in, and it will work. And like I said, you can replace the extruders. You just have to make a few timing adjustments to your firmware. And you don't have to flash the firmware to do it. You can do it in G-code commands before it starts printing. That's how I did it. I actually gave the commands to 3DP, Micron 3DP, for these extruders, and they are on their website in their help section. So if you have an Airwolf and you get that extruder set up, you can get the actual commands you need right off their website. Alright people, well, you now know you can replace your heater resistor with a heat cartridge. You now know how. I hope I've been able to help you. You all have a good day.